Lesson 3.6, Mathematics of Finance. In this lesson, we're going to review some ideas we've talked about in the past when dealing with compound interest. And then towards the end of the lesson, we're going to learn a few new formulas that allow us to calculate the present value or the future value of annuities. First thing we need to do is review the difference between simple interest and compound interest. Okay, simple interest ignores any idea or effect of compounding. Your interest is only based on the original principal amount you have. Compound interest is different because you earn interest on interest you've already earned as well as the principal amount. Okay, the main idea, the more times the interest is compounded throughout the year, the more money you will earn if we're talking about a savings account. There's 4 different formulas we can use when talking about interest earned. A stands for the amount of money in the account. P stands for the principal amount, the amount you start with. N is referring to the number of years, and R is your interest rate. Okay, down below you can see we have a K value. K is referring to the number of times being compounded, and T is just like N refers to the number of years. In the first example, we're going to compare simple interest versus an annual compound interest. Suppose Brent Smith invests $20,000 at 4% annual simple interest, and James Hetfield invests $20,000 at 4% annual compound interest. We're going to compare how much money each will have after 15 years. So for Brent Smith, we have this first equation, which is referring to simple interest. And then for James Hetfield, we have this equation, which is slightly different because this is referring to compound interest. Now you would just plug each of these in on your calculators. For the first one, you get $32,000. And for the second equation, you get approximately $36,018.87. Dealing with money, so of course we're going to go to 2 decimal places. So you can see by using compound interest, you earn much more money in the end. Example 2, we're going to compare compounded multiple times per year and compounded continuously. Suppose Corey Taylor invests $15,000 at a 3% interest rate compounded monthly, and Benjamin Burnley invests $15,000 at a 3% interest rate compounded continuously. We want to compare how much each of them is going to have in their account after 5 years. So again, you would just plug these into your calculators to get those approximations. For the first one, compounded monthly, that's why in our formula we're dividing by 12, and we have 12 in the numerator of our exponent. That's our K value, how many times it's being compounded per year. For that, you would get approximately $17,424.25. And then for the one compounded continuously, you get approximately $17,427.51. So compounded continuously, you're going to earn more money. In general, the more times you compound per year, the more money you're going to earn in your account. Compounded continuously is going to earn the most. Before we move on to the new ideas we're going to discuss, we have to go through some vocabulary terms. The first one being the annual percentage yield. So with different rates and different formulas for compounding interest, it's sometimes difficult to determine which option is going to be the best. So the APY makes it easier to compare which option is the best. So you're taking the interest rate and the number of times compounded per year to come up with a value that's called the APY, and then that allows you to quickly identify which one is giving you the better option. An annuity is a sequence of equal periodic payments. Future value is referring to the total value of an investment based on those equal periodic payments. An example of this would be putting money towards a retirement account. And then present value is the net amount of money you put into an annuity. An example of that would be a loan or mortgage. Here are the 2 formulas for your future value of an annuity and the present value of an annuity. R represents the dollar amount of each payment, N represents the number of payments, and then I is the interest per pay period. Okay, so say you're making monthly payments. To calculate that I value, you would take the interest rate divided by 12 to get that interest per pay period. This next example, we're going to find the future value of an annuity. At the end of each quarter, Elias Soriano makes a $250 payment into the MVP mutual fund. If his investments earn 6.23% annual interest compounded quarterly, what will be the value of his investment in 25 years? So we know we're going to use the future value formula. R represents the payment amount. I is the interest per compounding period. N is the number of payments. So filling in the information we know our R value is $250. And then we have 1 plus I, the interest, that's the interest per compounding period. So we take 0.0623 divided by 4. And the reason we have to divide that by 4, we know this is compounded quarterly. Quarterly referring to every 3 months. And then we raise that to N, which represents the number of payments. He's making a payment each quarter, so that would be 4 times a year times 25 years. He would make 100 total payments. And then we have minus 1 all divided by 0.0623 divided by 4, that value of I. Now, if you plug this in on a calculator, you will get approximately $59,234.27. Okay. I would recommend you go through and try to type this in on a calculator. You're going to have to use either multiple steps or many parentheses to come up with this value. So make sure you're able to type it in correctly. The last example, finding the present value of an annuity. Jonathan Davis buys a house for $675,000. What are the monthly payments for a 15-year mortgage with a down payment of $135,000 if the APR, the annual percentage rate, is 3.2%? So the present value in this case is going to be how much he owes on the house. So we have to take the $675,000 minus the down payment of $135,000 and left with $540,000 that he still owes on that house, equal to R, which represents the value of each payment. That's what we're looking for in this problem, times 1 minus 1 plus. To calculate I, we take 0.032, that rate, divided by 12 because it's monthly payments, and then raised to the negative 15 because it's 15 years times 12 payments per year. And that's all divided by 0.032 divided by 12. Again, you're going to plug this in on your calculators and simplify and isolate R. In this case, it's probably easier to simplify this part on the right and get a decimal approximation because you're going to have to take 540,000 divided by that quantity to get R isolated by itself. If you simplify this part on the right, you get approximately 142.8079. It's going to be better if you can just use your calculator wisely and keep that exact value. But if you take the 540,000 divided by this quantity, you're going to get an R value of approximately $3,781.30. So that would be his monthly payment towards that house. In this lesson, we reviewed many ideas we've talked about in the past, those formulas dealing with compound interest and interest compounded continuously. And then we introduced some new vocabulary terms and those two formulas, one for the future value and the present value. Make sure you understand those two formulas and the parts, especially I. I is not simply the interest rate. You have to take the interest rate divided by the number of times it's being compounded per year.